Welcome everyone to the public launch of our final report, Ore Sand, a potential new solution to the mine tailings and global sand sustainability crises. This report is dedicated to the families who have lost loved ones as a consequence of mine tailings storage facility failures worldwide, and to the artisanal sand miners who work in circumstances of poverty and informality to mine the material that constructs our world. This research is a collaboration between the University of Queensland and the University of Geneva. The research team is present today with us. While we are too many to introduce individually, you could see us from our background, our uniformed background we've put on today, and would hopefully have the opportunity to hear from us or some of us during the Q&A. The agenda today is as follows. We will be inviting Professor Pascal Peduzzi very shortly to introduce the global issue before going to Professor Daniel Franks, who will be then sharing the key findings from our study. Next, we have three very special guests with us today to discuss some of these findings before we open up to a Q&A. And we would like to ensure all contribution to the floor is heard, and that's why we invite you to make them through the chat. Our moderators will put it through to the right researchers. So thank you, Josephine. So without further ado, I would like to invite Professor Pascal Peduzzi from the Department of FA4 for Environment and Aquatic Sciences at the University of Geneva to start us off with an overview of the global sustainability challenges at hand. Professor Pascal Peduzzi, please.
Thank you, Stephanie. So welcome everybody. And indeed, what are questions? How much sand do you think you've been using today? And since you can't talk, we'll say the answer straight away. It's about an average worldwide of 17.3 kilograms per day for the 7.9 billion people we are. So in total, it's amounting to 50 billion tons per year. And 50 billion tons is such a big number, it's hard to imagine. So just to capture what it is, it's enough to build a wall of 27 meter high, 27 meter wide, all around the equator every single year. And that's the amount of, you will say, why are we using so much sand? We're actually using that for roads, for building, even for making glass, for reclamations of territory on the sea. We use it for many different purposes. In fact, our entire development is based on sand and gravels. Imagine without sand and gravels, you can't make any concrete, so you can't make any tunnels, any bridges, health facilities, airport, buildings, and so on. So all the dams and all these infrastructures that we are using is more and more made of concrete, asphaltums, and different glasses. Even the screen you're looking at is made of sand. The chips beyond the computers is also made of sand. So we are tremendously dependent on sand and gravels for our development. Yet we are still considering that as a common material. You cannot withdraw 50 billion tons of any things out of the environment without having a large impact. And those impacts actually is not only an environmental impact, but also societal impacts. And we started to look at this issue very recently. Until a few years ago, no one was really looking at this issue of sand and how much we were depending on it, and that there was a need for really finding solutions on either reducing the amount of sand or substituting. Now, in 2019, we published a first report on sand and sustainability, and that led to a resolution by the United Nations Environment Assembly, that the resolution 19 on mineral resource governance, that's dedicated a specific paragraph on how we should be dealing with sand. And later on, that the World Conservation Congress in 2020, organized by IUCN, there was a call for urgent call for management of marine and coastal sand. So it seems that now this issue of sand management is becoming much more present. And you have to imagine that in Asia and in Africa, we have a booming of population. Actually, African population is going to double from now to 2050, adding another 1.27 billion people. On top of that, they will be migrating from rural area to urban, plus catching up on development, meaning that there will be a huge demand for sand and gravels, and this is not yet really anticipated. On the other hand, we have another challenge. So we're talking about finding a solution, and there are many solutions, but one that really one that is at the same kind of volume So we look at the mining industry, and mining industry is extracting between 30 and 60 billion tons of material leftovers on tailings. So it's leftover material that is not being used by the mining industry. So this is a challenge for mining operation because they need to shift this material to stabilize the slopes, and sometimes it leads to disasters like mud flows and so on. So it's also a question of a hazard. And anyway, it's a waste because it's unused material. So the idea of this research is to find a way to use this material. And we call it ore sand because it's sand that is done in parallel of extracting the ore. And that's what we're going to talk about. Back to you. Thank you.
Thank you, Professor Pascal Patrizzi. Next, we're moving straight into the main part of today's launch. We'll be sharing with you a short introductory video of the study, which will hopefully provide you with a good framing of the research. Before going to Professor Daniel Franks from the Sustainable Mineral Institute at the University of Queensland and the project lead of the current study, who will be taking us through the key findings of our research.
So good day, everyone. It's fantastic to be sharing this work with you. As Stephanie mentioned, my name is Daniel Franks, and I'm a professor at the Sustainable Minerals Institute at the University of Queensland, where I lead the Development Minerals program. Change slide, please, Josephine. My job today is to share with you the major findings of our research. I'll be summarising of a wide range of colleagues who have contributed to the study, most of whom are online to field any questions that you may have. Change slide, please. So tailings are the crushed rock left over after mineral processing. And depending on the type of ore, tailings often contain metals that can mobilize into the environment. The facilities where this material is commonly stored also fail more often than is acceptable, causing widespread downstream devastation. Mining waste, both waste rock and tailings, are the world's largest waste stream. In research that I published with colleagues in the Nature Journal Scientific Reports, we calculated that around 13 billion tonne of tailings, additional tailings, will be produced each year over the coming 5 years. That's more than 1.6 tonnes for every person on the planet. When we combine that with the waste rock in the mining industry, we get a figure of around 30 to 60 billion tonne of waste that the mining industry is responsible for each year. We also found that more than 10% of facilities built to store tailings have failed to be certified as stable or have experienced notable stability concerns at some point in their history. For upstream type tailings facilities, the figure is 18%. Previous slide, please, Josephine. Thank you. We also estimate that there are around 8,100 active, inactive, and closed tailings storage facilities in the world. Up until now, we've largely accepted that tailings are inevitable. Even when we've attempted to do something about this waste problem, we've accepted that we can't do much about production. We've developed ways to store them as a wet slurry in a tailings storage facility, to dewater them and store them as a dry stack, to rehabilitate them and cover them with soil, and to try to stop them from leaching metals by mixing them with other materials. We've also tried to find ways to repurpose them directly as construction materials. But because this approach takes as given the physical and chemical properties of the tailings, uptake of repurposing as a circular economy solution has been slow. In most cases, they're not quite fit for purpose, and people aren't all that enthusiastic to make things out of the waste. Today, we're presenting another way to think about materials in an ore body. The target commodities, which are mostly metals for ore that produce tailings, make up only a fraction of the ore, and for some ores, less than 1%. A large fraction of the rest of the ore is typically silicate minerals, which are the main ingredient of the sand and crushed rock that we use as construction materials or industrial minerals. At the moment, mineral processing circuits are designed to extract that one metal commodity out of the ore and create a pure product. We've got incredibly good at doing that, and the grade of the ores we're mining are dropping, meaning much more waste is now produced, and it will be more into the future. Change slide, please, Josephine. Recent devastating tailings facility failures have challenged how individual companies, the industry, and governments deal with mining waste. While Vale in Brazil were the locale of the most prominent of these recent failures, the truth is that this is an industry-wide problem, and scores of other facilities have failed across the industry and the globe. The public expects nothing less than a transformation. They expect us to use this moment to innovate and drive real change. Governments have introduced new laws, and the UN, International Council on Mining and Metals, and responsible investors have introduced the global industry standard on tailings management. So in my presentation today, I'm going to share some of the major findings of our work and how these findings might drastically reduce the volume of waste produced around the world. Next slide, please. So our research asks, why don't we add mineral processing circuits to take out the silicates and other useful minerals as byproducts before they become tailings waste, and create a by design, something we've named ore sand. Our work builds on the innovations pioneered by Vale over the past few years, and I'll share the results of our independent testing of Vale sand. So what do we mean by ore sand? Ore sand is a type of processed sand sourced as a byproduct or a co-product of mineral ores. Typically, it's a result of mechanical crushing and grinding, different physical and physiochemical beneficiation processes for recovery of the mineral, including optimization of these processes for and additional processing stages to achieve the required properties that we want out of a sand. Next slide, please. Ore sand is just one in a family of aggregates that can be used in construction, land reclamation, and industrial applications. Although these applications seemingly make use of the same resource, many of these different sectors have their own standards or specifications. And moreover, the construction and industrial applications, the type of sand used for, is often determined by tradition, which in turn has evolved with different locally available raw materials, different geographic conditions, and different measurement systems. In construction, several of these traditions have evolved into norms, standards, or codes, which are in many locations a barrier for the use of alternatives. And standards play a less important role, though, in land reclamation and industrial applications. So engagement with standards setting institutions is really important if we're to seriously look at the potential for uptake of ore sands. Next slide, please. So data from Jim O'Brien and the Global Aggregates Information Network indicates that sand consumption is highly unequal around the world, with rates dependent on a range of different development factors. In most regions, the sand price for construction and land reclamation reflects the cost to extract, around $3 to $10 per cubic meter, and the cost to transport. In regions with sand shortages, though, the price can be considerably higher. Construction-related applications are the biggest market by far for sand in both volume and total market value. And the industrial sand market has an estimated volume of around 200 to 100 million tonnes per year, and it's the smallest market. Per tonne, though, industrial silica can command the highest prices, and depending on the quality, can be between $12 and $60 per tonne, with very pure silica sand commanding even higher prices still. Next slide, please. So our research team independently sampled ore sand from Vale's Brucutu mine in the state of Minas Gerais in Brazil. Vale's first mine with full-scale sand recovery operations and an environmental license for sand production. Next slide, please. The typical mineral processing options for iron ore include ore size reduction via crushing and milling, classification by sieves and cyclones, mineral recovery via gravity separation, flotation and or magnetic separation, and dewatering. The Brucutu plant produces iron ore concentrates in the form of sinter feed and pellet feed fines. And all major processing steps can directly contribute to the recovery or co-recovery of sand. Compared with the rejection of all the remaining components in the ore as tailings, additional steps to recover ore sand might include segregation or separate handling of the silica-rich components, or classification by cyclones and filtering. Next slide, please. So what we found was that the particle size distribution indicates that Vale sand is a silky, very fine sand. The content of the fines is slightly above the maximum recommended level for manufactured sands if we were to measure it by weight percent, or slightly lower if we were to measure it by volume, indicating that for some applications, it's necessary to blend Vale sand with other sands. Next slide. The sample is mainly represented by silica and iron oxides with a low alumina content and minor concentrations of other major oxides. All the trace elements are present in very minor concentrations, significantly below the environmental thresholds and the average level for most soils. We conducted leaching tests and they confirmed that the material is non-toxic with metals below the detection limits for most metals. Next slide, please. Now, the particle shape and the texture can significantly affect the performance of aggregates in different applications, in particular the workability and the strength of concrete. So generally, the use of angular aggregates allows the achievement of a higher compressive strength for the concrete, whereas rounded particles are less water and cement for the same workability, while a percent of elongated or flaky particles has to be restricted. Next slide, please. So ore sand falls somewhere in between manufactured sand produced from crushed rock and pit and river sand. And this was confirmed by mineral liberation analysis performed on the samples. Next slide, please. The higher shear strength, a higher shear strength may be required in order to provide more safety and stability for structures, in particularly for aggregates used in road base or construction fill or land reclamation. We found that significantly higher shear stress was achieved under higher loads, which indicates a high level of kind of interlocking between and resistance between the particles when the material is more compacted. Next slide, please. And because there's a relatively high silica content and very low level of trace elements in the sample, we did some additional testing using magnetic separation and gravity-based separation to see if we could reduce the residual iron oxides and potentially meet the chemical requirements for silica sand that might be used in industrial applications like glass manufacturing. And the tests we found were successful in achieving a very high silica content product. Next slide, please. The production of a high quality silica sand product would open up Varley sand to additional higher value industrial sand markets, as shown on the slide. Next slide, please. We also undertook a life cycle assessment to evaluate the environmental impacts of Varley sand. And I'll present just some of the findings here. Depending on whether the greenhouse gas emissions from the production of Varley sand are considered a byproduct of waste management or as a co-product of iron ore mining, which would have two slightly different methodologies, we estimate that each kilogram of Varley sand is responsible for between 0.5 and 0.6 grams of carbon dioxide equivalent. And this is substantially lower than the average emissions from river sand and sand from open pits. Previous slide, please. In Brazil, as well as marine sand from dredging in the UK, and as well as manufactured sand. Next slide, change, please. Emissions from transportation are larger than the emissions from production for all sand, basically. Selecting the right transportation mode and the right distance to markets is therefore really critical for ore sand to be competitive with natural sand in terms of greenhouse gas emissions. The life cycle assessment of Varley sand shows that substituting naturally sourced sand by ore sand could potentially lead to net reductions in carbon emissions. The emissions profile of transportation will vary by the mode, but come at a head start compared to other sands due to the low emissions during production. The question is ore sand catered as close to markets as other types of sand? Next slide, please. So from the case study of Varley sand, we also considered what the potential might be if ore sands were scaled up to other types of ore bodies around the world. Next slide, please. And if this were to become a reality, we'd need to ensure safeguards for sustainable and just transitions from the present extraction of sand from natural waterways to substitution by ore sand. And there's at least three topics that are important. As more potential for ore sand is explored in more complex ore bodies, it's important to ensure that processing solutions are found to eliminate potential contaminants, such as sulfides, which are present in ore bodies that we usually mine for, say, copper or gold. Consideration also must be given to how the extraction of the ore sand byproduct might affect the leftover or the residual tailings in terms of their physical and chemical composition. And finally, just transitions are necessary for small and medium-sized enterprises and artisanal and small-scale miners who may potentially be displaced by ore sand alternatives. Next slide, please. We undertook a mapping of worldwide mineral ore extraction and processing with sand and aggregate consumption to understand the existing and the potential hotspots for ore sand. Now, there's a number of locations in the globe where ore sand is likely to find a very significant demand. And it's no surprise that Minas Gerais in Brazil, the location of the Brucutu mine is one such location. So blue on this chart is demand for sand and red is potential supply of ore sand. Next slide, please. A very substantial fraction of the world aggregate demand is within range of a potential source of ore sand, with over half of global consumption within 100 kilometers of a potential source. Next slide, please. If we look at that further, we calculated that the distribution of this local demand by country it reveals the parts of the world where the greatest absolute potential for substitution exists. So whilst demand in China dominates the global picture in absolute, in relative terms, there are heaps of countries where there's scope for substitution. Next slide, please. Including a number of countries where the overall volumes are lower, but where the proportion of national demand that could be substituted is really high. Next slide, please. Looking at it from the perspective of the mine site, rather than from the perspective of the market, almost a third of mine sites could find sufficient demand for ore sand within 50 kilometres. If coarser aggregates could be produced, potentially by crushing waste rock or by pre-treating or by adding coarse particle flotation, almost half of all mine sites could find sufficient demand for aggregates. Next slide, please. Finally, we explored how we could cross the chasm from innovators and early adopters like Vale to the majority of the sector by performing interviews with a wide range of stakeholders. Next slide, please. Our findings show the chasm and crossing this chasm will require, one, developing a niche with clear relevant advantages. They might be cost or security of supply or reputation risk compared to naturally sourced sand, and a clear story for abiding by sustainability requirements. Two, find allies in the aggregates market and in the related sustainability discussions and developing real-world testimonies. Three, reframing the agenda with a new narrative that's pragmatic, targeting the interests of mainstream players in the aggregates market. And four, enabling market access with a national and regional lens. Next slide, please. In conclusion, ore sand is a product by design, not a repurposed waste. Currently, due to the very fine grinding by most mine sites, ore sand is limited by grain size. With coarser processing, like innovations, including coarse particle flotation, a coarser product can be achieved that would not require blending. Encouragingly, sand markets align with tailings risks. So the sites close to urban centres present both a sand market and a rationale for tailings reduction. Wider adoption of ore sands needs to address the potential presence of contaminants, the management of residual tailings, and broader effects on the market. And ore sand has the potential to provide a solution at scale, with almost a third of mine sites in the world able to find at least some demand for ore sand within a 50-kilometre range, with at least 10% tailings reduction. And from a consumer point of view, about half of the global sand market is in the vicinity of a potential local source of ore sand. Okay, next slide, please. Thanks very much for the opportunity to share our findings, and I'll hand back over to Stephanie.
Thank you, Daniel. We've heard many interesting points brought up during the presentation, and now we would like to invite our guests to join us for a discussion about what we've just heard and share their thoughts about the study. Our first guest is Dr. Emil Schiepers from Vale, a trained metallurgical engineer and someone who is known for his passion for sand. Dr. Emil, welcome. So Dr. Emil, Vale is pioneering the production of ore sand from iron ore in Brazil as part of the company's effort towards tailings reduction and circular economy solutions. We know you've been a champion in driving innovation within the organization, especially with different projects in exploring ways to use Vale's sand. Could you perhaps share with us your journey from the early stages of the idea, from piloting to the implementation and now to the current study, looking at the potential of ore sand as a whole? And how does this idea of one solution to two sustainability challenges play into some of the initiatives currently taking place within Vale? Dr. Emil, please take it away.
Thank you very much. It's a pleasure to be here. So for me personally, the the journey started in 2013 during my executive MBA here in Switzerland at EPFL. So at the beginning, each MBA participant was challenged to develop a business idea, a business case for a subject that was something we care about. And then you had to pitch it to the class. So there were about 30 participants. And then you had to convince 4 classmates to join you in your idea. Quite a tense but interesting first week. And at the end, I could convince 4 professionals to join me and help out. And this business case at that time that emerged was transforming the sandy part of the mining residue into quartz surfaces or engineered stone that you can use for kitchen countertops. Some of you might have it in your kitchens. And of course, back then, the word ore sand, as it is defined here today, didn't exist. I wish it did, but that's exactly what we had in mind. It's the sandy part, without having the lexicon. So, well, when the MBA finished and the business plan was ready on a theoretical scale, that business plan entered the Vale ecosystem, where it started to interact with other like-minded Vale ore sand ideas and people at the time, which there certainly were. Some of them are online here today. And finally, it merged into what we called at that time the Vale Quartz Project, which aimed at transforming the mining residues into high-quality sand resources, residue from a resource, for a more broad range of applications, not just the countertops. And I have to be honest, in 2014, defending the idea of producing sand was not easy. Sand is cheap, sand is everywhere. These were very understandable responses at the time, I think. So in 2014, when the United Nations Environmental Report came out called Sand Rarer Than One Thinks, and we have the author here today, Professor Pascal Petuzzi, it gave the project internally at least a whole new dimension. It clearly said in an authoritative voice that usable sand is not an unlimited resource, that it has real value, and its extraction from our environment has real impacts, not just on the environment, but also the surrounding communities. And we have to use it wisely. So from that point on, so from 2014 on, it became very clear that producing ore sand, a deliberate product by design, not only would help reduce mine tailings, but could also become a sustainable alternative at scale to the sand needs of our society that was so eloquently highlighted in that report. Since that time, there has been many reports. So that is what we strongly believe today, and what we believe then is one potential solution for 2 sustainability issues. And I mean, having said all that, the ore sand must be a marketable product comparable to natural source sand. And so this report, as it's shown, Vale's ore sand has the potential to do just that. And Stephanie, the second part of your question was, how does this idea of one solution and 2 sustainability issues play within Vale, right? We believe in it very, very deeply, in this idea. And we think the best way to honor this idea is to get to work. So I want to explain to you a little about what we've done in Vale and what we intend to do in service of this idea. So let's start with talent. Approximately 2 years ago, Vale set up a co-products group dedicated to look at ore sand. That's all they do. Currently today, this co-products group has an operational, a marketing, and a sales dimension. And approximately 20 people are working in co-products group full-time and growing. So investments, Vale has up to now invested about 10 million euros, which I think for today is about 12 million US dollars. It may not sound enough, but I'd like to remind you, as the report so eloquently put, the sand business shares benefits from existing assets of the iron operation as it is. So only slight, relatively minor CapEx adjustments were needed for us to produce the sand as a deliberate product. And a lot of that 10 million euros also went towards R&D to make sure that we just not maintain the quality, but how can we improve the quality to find better markets. So volumes, the report refers to Brugutu, which is a beneficiation site in Brazil. In 2021, this site produced 250,000 tons of ore sand. This year, we're looking at producing around 1 million tons. And beyond 2023, we're looking at up from 2 million tons of ore sand from this particular site. But it's not the only site that we are committing to. There's also this year starting production at a beneficiation site in Viga, and we're testing also at another site in Itabira. With regards to where the product goes, so take this year, approximately 1 million tons of ore sand. 80% of that will be sold under contract, and 20% of that is donated. In terms of applications, so where does it go? At the moment, the major focus is on construction, as this is the application that offers the largest production at scale and volume reduction opportunities. Now, one example of the donation is that we donated some road construction materials to 2 local municipalities, Paraújicocais, Cate in Minas Gerais. We're not only focusing on construction, we also currently have a portfolio of more than 20 different initiatives driven by the co-products group and other stakeholders within Vale, concerning 12 market niches, different market niches. Just the graph that Professor Daniel Frank showed around the different opportunities once you move into the higher quality scale. We maintain around 40, we maintain partnerships with 40 universities. 2 of them are present here today on the logos that you see in the project team, as well as companies with different sectors and government agencies. And in addition, Vale Sand was also approved by the respected Brazilian laboratory, Instituto de Pesquisas de Tecnologias. If you translate, it's the Technology Research Laboratory, IPT in Brazil. So this is an important step for Vale. Now, I'm almost finished, Stephanie. I want to say 2 more things. The first one is about testing. So the first project at pilot scale was called in Portuguese, Fábrica de Blocos, or Pico Block Factory. It was built in the Pico mine, and it was opened in November 2020, so about a little bit more than a year ago. And this is a factory that produces precast products, flooring, concrete blocks, by taking away 100% of the natural, by substituting 100% of all the fine natural aggregates with Vale sand and tailings. And in a little while, I'm going to post a link of the opening into the chat. And anyone who wants to go, they can just read about the opening of this. And then something just to make sense of how we take research into industrial testing itself, which is of course critical, is 5 years of laboratory testing within Vale showed that a road built using Vale ore sand in all 4 layers of road construction could potentially increase lifespan by around 50% and decrease the cost by 20%. This was the laboratory. So how would we test it in the real world? Well, we built 0.5 kilometer of road, and we inaugurated this piece of road a month ago, April, at our Cauê mine in Brazil. So for the next 2 years, all the heavy trucks from the mines will drive over this road continuously. It has 96 sensors for pressure, temperature, deformation, humidity. And the study was done in partnership with the Federal University of Itajuba and COPE UFRG. And that's just to show you that to give you a flavor of how much we believe in this idea. Thank you very much.
Thank you, Emil. You've mentioned how Vale is testing its ore sand currently in several infrastructure projects. I believe that's a great segue to our next discussant, Laura Powers, who is a senior consultant at YA Engineering Services and an adjunct professor at University of Wisconsin-Milwaukee in the Civil and Environment Engineering Department. Laura is also a part of this study's independent scientific committee. Laura, welcome.
Thank you very much, Stephanie.
Laura,
yes?
Oh, sorry, you have so much to share, but I just would like to put in a quick question. You have a vast experience assessing the performance and condition of existing, but especially new construction materials. As we know, the uptake of alternative materials is seldom clear-cut. There's no hard and fast rules when it comes to these things, but perhaps there are several pathways to consider. So I guess my question to you is that what do you see are the roads towards acceptance for ore sand, and what, in your opinion, would need to happen for a potential solution like ore sand to scale with the possibility of bigger scale implementation? Laura, take it away. Thank you.
Okay, thank you. Yeah, I'm sorry for speaking over you. The question of how does ore sand gain acceptance for use in construction materials and what needs to happen for a larger scale adoption and implementation are really connected by the fact that the construction industry is highly conservative. No one wants to be responsible for a bridge or building collapse, and we've certainly seen some of this on the news in the last few years. And what this means is test, and more test, so that any potential for harm is identified and can be avoided. And we've heard some of this from Emil just now and from Professor Franks. And we have to consider that not all ore sands are, they're not all iron ore sands. There can be sands derived from recovery of a number of different materials. So we need full characterization. And that's where the laboratories that I've worked in over the years come in. These labs have performed independent third-party testing to assess how materials such as aggregates and cementitious materials would perform in service. So in many countries, there's an overall specification for aggregates for use in concrete. That's the area that I'm most familiar with, concrete and grout and mortar. In the US, that standard is ASTM C33. This specification references a variety of standard test procedures, physical testing, chemical testing, petrographic characterization. All of these are designed to ensure that the products made with the aggregates that pass the tests will be durable. In the US, ore sand would be marketed as a manufactured aggregate in the same category as crushed and graded rock. And I think the marketing is really key. The testing is absolutely critical, but the marketing is key. Why would this aggregate really be treated differently from any other manufactured aggregate? Once ore sand passes the standard tests, it can be incorporated into concrete mixtures to determine whether aggregate affects engineering properties. And when we have aggregates with limited or no history of use, you need to compare their performance against well-characterized aggregates that everybody knows about to see how they measure up. In some cases, the new aggregate can actually enhance certain important engineering properties like strength, and we've heard about that. Something like this happened with the movement to replace part of the cement and concrete with fly ash many years ago, and testing determined that replacing some of the cement helped to control adverse chemical reactions in the concrete and improve durability by modifying the microstructure to make the concrete denser. These benefits were enough to offset concerns about things like slower strength development at early ages. And this happens because chemical reactions that need to occur are delayed. So we're thinking that maybe ore sands can provide benefits that would really speed their acceptance. So assuming that all of the testing has been done and results are highly positive, how do we get ore sand accepted? And that was the second part of your question. There are avenues to pursue. First, for any novel material, and of course, novelty wears off once people have been using it. The characterization of the material and the test results would be published and presented at technical conferences and put before technical committees of standards organizations. Everyone needs to know that it exists, what its characteristics are, how to use it, where to get it. This gets into the early adopters scenario. And it's often said that codes and specifications are slow to change and they're the biggest obstacles to the acceptance of new materials. But what I've been seeing is that performance-based specifications have been around for years. And we're looking at a transition from prescriptive specifications that tell the contractor what to use and can actually limit or exclude alternatives that are already out there. Performance-based specifications focused on the required properties of the finished work, which for many of us would be, we want enhanced durability, we want to consider global warming effects. I think the focus on sustainability and global warming challenges will provide an even greater push in the direction of performance-based specifications. And in my experience, performance-based specifications allow everyone to come to the table in the planning stages of a project to discuss how they intend to achieve the stated goals. And this provides a more even playing field for different materials to be used. So with initial acceptance, the keys to scaling up the use of ore sand involve marketing to show product consistency, availability, and cost competitiveness on the supply end, and then regulatory promotion and performance-based specifications on the user end. There could be other things too that I haven't considered at this early hour of the morning, but I think these are the main ones.
Thank you, Laura, and thank you for joining us from Wisconsin and early at this hour. And I think like what you've mentioned and shared with us ties back with what Daniel has mentioned on the need to cross the chasm and what it will take for us to cross this chasm between the early adopters to the early majority. And with that, I'd like to introduce our next discussant, Kristin Sveno, who is the Director of Innovation at the International Council on Mining and Metals. Kristin,
hi, Stephanie.
Welcome. Hello.
Thank you.
Hi. Kristin, the International Council on Mining and Metals, ICMM, has been pushing for innovation and exploring breakthrough technologies to help reduce production of mine tailings. Could you share with us your thoughts on how does ore sand potentially fit into ICMM's tailings reduction roadmap and strategy towards a circular economy or circular economy solutions? And what does an innovation like ore sand mean for the industry? Kristin, thank you.
Thank you, Stephanie. I just want to say, I want to start by saying this, how exciting this is. I mean, how a fantastic turning point this kind of event, and in particular this research, is for the industry. This, and why is this? I mean, this kind of research clearly allows us to look at the industry through a different lens, raise new questions, look at our industry in a way that we have not looked at it before, at least in to the degree of depth that this research is providing us. It unlocks value that has been hidden for a long time. And it opens really a space for a new conversation that is not linked to marginal or small changes in the industry, but actually could open the door for radical changes that drive, broader development and really shifts the conversation to a more positive tone. So this is very exciting, I have to say. How it links to the work that we're doing at ICMM. The second point that I think is very important to highlight, in Professor Franks has already talked about this, is how the topic of tailings is such an important point, an important conversation that we're having at ICMM. Obviously, after the disaster in Brumadinho, we felt out of principle that we had to deal with this conversation in a proper manner, and that's how we have done as an organization. We have engaged with PRI and with the 27 CEOs that represent our council, and there is a very specific piece of work that has been going on for years now to really look at, how do we achieve best practice across the industry to make sure that we have no chance of this kind of terrible events to happen again. And more related, and as a result of that conversation, is that we started looking at the tailings reduction roadmap. We started thinking, okay, if we think about tailings, we can have a fantastic area for innovation. And if we think about the whole process of mining, as mining and refining, and the whole process that we have across the different commodities in our membership, how can we bring incremental, transformative, and disruptive innovations so that we can place these different technologies, processing, and approaches to mining that allow us to, well, first of all, reduce the volume of tailings, but also going forward, how can we completely disappear tailings from the mining production process? And that's what we have done. So one of the first stages was a very thorough process of engagement with our members, and with those providing the solutions for reduction and elimination of tailings. And then we map those solutions across these kind of lenses. Now, what is incremental, what could be transformational, and what could be disruptive? And so just to give you some examples, we have sensor-based and ore sorting technology, obviously tailings database, coarse flotation, waste valorization within the incremental part of the innovation. And then, well, we have no waste mine architecture, non-chemical extraction and dry processing, more on the transformative side. And then on the disruptive side, we have in situ teaching metal and sub-projects, smart commutation, so that we get to selective breakage and enhanced liberation in the process. So as you can see, these are technologies or enhancements of processes that will touch on a number of elements in the current way we do mining, but we're starting to understand them in detail. And one of the things that we also wanted to understand, which has been done so well in the research that Mr. Frank was presenting, is to understand what is the potential impact on tailings reduction, and what is also the duration for first commercial use. And so in that way, we have started to map, how long we are in terms of years to actually get to this technology and exploit the impact that we could get. But also, what is the impact? How far can we get if we apply this technology? And we have done some initial mapping around that. The interesting thing is that this could be transformational. So this could actually start to shift and apply the lens that Professor Frank was applying in his presentation to something that we consider now a liability, tailings. We can actually look at tailings as a driver for smart mining, increasing productivity, increasing efficiency, and really look at our processing to get the most of our current approach. But the most interesting bit is that even when we have tailings, we start to look at it as a resource. And so how can we exploit the different materials and elements that we find in tailings to really enhance the recovery of as many products that we can recover? What I really like from the research is that sands are recovered even before they become waste, which it might look like a small difference, but it's not really. It really brings up to the heart of increasing productivity of the investment of the asset. And although you could do the same when it becomes waste, but when it becomes waste, you have other elements that you need to take care of in terms of stability of the tailings and many other elements that come with the tailing management itself. So having this lens on, or this focus on recovering the sand before it becomes waste is something that could be applied to to many other materials as we look at tailings more broadly speaking as a resource. Now, one thing that I would like to do is now step back and link this conversation with the broader circular economy project that we have and are developing with our members at ICMM. The circular economy is a lens that we should really look deeper into when we think about mining and minerals and metals. One thing that we have discovered in our engagement is that minerals and metals are, bulked into the definition of virgin materials. And so when we look at the definition of the circular economy, there's always a circle with the reduction, repurpose, recover, and recycling. And then you have a little tail of virgin materials that needs to be reduced or completely closed, with the idea that you will only depend on the circular system. Now, we need to think about what is the role of durables in that system. And when we think about the role of durables, what kind of durables we need? And if we think about the current commitments we have on climate, how those durables can play a role in building the stocks that we need to circularize those durables so that we can reduce emissions by increasing that lever, by pulling that lever as strong as we can. And if we think about that, we actually need to build stocks of durables, and minerals and metals are one of the most durable materials we have. The critical question is then what characteristics those durables need to have to enter the market and be part of that stock? Well, they need to come from operations that drive development, are committed to zero emissions, and can get as closer as possible to a regenerative model of mining. And there is where we find the proposal from Professor Frank linking perfectly well. If we expand this approach to its maximum, we will drive a regenerative model of mining, one that can drive the production of these durables to build a stock for the circular economy and circularize them to reduce emissions to be aligned to 1.5 degree scenario, but in a way that doesn't close the entry point for minerals and metals, but actually screen it to absorb minerals and metals that are driving development, reducing their impact at zero carbon, and really driving development. This is a lens of circular economy that joins the production side of minerals with the market side through the idea of the concept or the fact that what we produce are durables that are needed to forever circularize systems. And so within that framework, I think there is a very important potential to look at the study that has been developed, led by Professor Frank, in terms of, how can we expand this thinking in terms of creating a circular mine, a regenerative mine that drives the production of these minerals and metals with specific characteristics that we can trace, so that the market receives these durable materials to build a stock that then will drive the circular economy at scale and speed, but also almost the same as level of importance, drive the alignment to a 1.5 degree scenario. And just to give a sense on what we're talking about, if we increase the level of circularity across all materials from 8.6% today to 17, 18%, so if we double that level of circularity, we will be reducing emissions by 40%. And so really driving and understanding circularity in the broader sense, not only on the market sense, where we close the entry point for all virgin materials, but we understanding that entry point, at least for the next 20 to 30 years, will be linked to durable materials that we need to screen so that they are supplying us in a very specific way to build the stocks that we need. It's absolutely crucial. And the project that we have now been presented with in terms of production of ore sands is a fantastic example of what could come next in terms of regenerative mining, producing the metals that we need and the minerals we need for building the stocks in the broader circular economy. I'll leave it there and happy to expand on any of the points as the conversation evolves.
Thank you, Christian. Actually, thank you very much for that very interesting input there, especially how taking us through how ICMM is thinking about circular economy solutions and how you see the study on ore sand fits into some of the broader thinking that you guys have been doing at the ICMM. I would also like to thank all of our discussants once again for joining us here today. Without further ado, I'd like to hand the floor over to my colleague, Arno van der Welpen, who would now be facilitating the open Q&A. Arno, the floor is yours.
Yes, Stephanie, thank you. Thank you for giving me the floor. And thank you to all the participants who have enthusiastically been posting questions in the chat box. My first question goes to Artem. Artem, you have performed and characterized Wallis sand. In what way is this material representative for other types of ore sand?
Yeah, we probably have to start, Arnold, with the fact that on a scale, we have only first example appearing, Wallis sand. So we don't really know, at least we're not aware of any other large scale ore produced from mining. There are small examples which we are aware of, but usually it's a very small targeted supply of tailings-like material to substitute sand in some applications. So it's not the same. It's not a product produced by design. So that's the major difference. But we did look into some potential ore sand recovery from other materials. We represent the Sustainable Minerals Institute, so we work with many mining companies and many commodities, and have samples of different ores and of different tailings materials. So there is a potential to achieve. To our surprise, or maybe not a surprise for Valley, the Valley is a rather good example of ore sand in terms of mineralogy. So it's really hard to compete to achieve such high level of silica with relatively simple processing. That it goes back again how much effort you want to put into recovery sand. So Wallis sand it's a case where you can recover a lot and very relatively low cost, just an extra one stage and you get it. In terms of particle size distribution, again, Wallis sand is probably very typical. So we expect other ore sands to be typical as Wallis sand. Again, depends on the mine sites, on the type of processing, how you design. Even in the Wallis sand, we can see if you start recovering sand earlier, not at the end of operations, before it becomes waste, but from the very beginning, if you target sand, you may recover coarser material. The same story for other type of processing facilities. So we believe there will be a variety of ore sands, and Wallis sands is probably in a better part. So the other sands will be different, and but it's a lot of research required to confirm this point.
Thank you, Artem. I think that is very interesting. I take as a takeaway, there is a need to also classify the different ores and the sand that we then co-produce with those ores. Josephine, you have engaged over the last year with a very wide group of stakeholders, among others, the public sector, NGOs, certification bodies, extractive and construction industries. Laura already touched base on it, but based on your interviews, what are the key elements to bridge the chasm that currently is there between the production of ore sand and using ore sand? And perhaps if we can already touch base on perhaps different regional differences. Thank you.
Thanks, Arno. Yes, I think we saw the question coming up in the chat too about the regional differences. And that's quite a relevant question also because it will be very geographically dependent also, the adoption of these types of alternatives. In terms of crossing the chasm, as Daniel was also mentioning here earlier on today, there will be several factors in convincing this larger group of stakeholders to try out this material, as we touched upon throughout this conversation, as Laura was mentioning, testing, and demonstrating the ease of use, how this can be incorporated into sourcing procedures and processes will be another one. Will be part of this process over both short and long term. Another factor in crossing this chasm is definitely by reframing the agenda here, working to update norms, certifications, technical sustainability standards to really incorporate sand sourcing and material efficiency into these standards and really therefore enabling access another way. On the ground and in terms of geographic differences, what we also observe through the stakeholder data that you can find in this report is that a key concern in trying out these materials is often, do these materials, or in this case, for example, all sand, does it match the constraints, the needs, or the expectations that they're facing in a given situation? So is it compatible with performance requirements, for example? For example, in Switzerland, there is a legislative requirement that obliges new construction to include 25% recycled aggregates. And that is driving an increase in uptake of alternative materials. So it's also highly context dependent to ensure that the entire policy and legal framework works towards facilitating this type of alternatives. Perhaps as a last example, one of our engagement in Syria alone, when we were looking at that context here of alternatives in that region, well, here mine tailings, they're known to be available and suitable as alternatives to naturally occurring sand. However, the cost of transport is currently a barrier to using these materials here in construction beyond local areas. So often, even though the product might be considered good on paper, then the preceding technology concept of product, there's a lot of context dependent factors to take into account. But much more info available in the report. I don't want to spoil it here.
Thank you, Josephine. I do think you wrote some very interesting paragraphs on place-based perspectives. So I encourage everyone to read into the report. Martin, you have performed a global analysis of sand demand in relationship to the volume of tailings and mining waste produced. There came up a question in the chat. It seems that none of them are in the EU. Can you explain a little bit on this?
There is a lot of mining activity in the EU. The problem is there are so many people that a lot of the metrics that you would design to try to identify hotspots, as we've been calling them for this process, are not being highlighted there because the demand is so high from the population of that region. However, I think it's a good opportunity to emphasize that this local demand is just the first step in this analysis that we've conducted this year. What we're looking at and what we have emphasized in the report is the need for both consumers and potential suppliers to find each other. So for us to sit with all the mining sites in the whole world and all the people in the whole world and try to match them up is something we're going to try to do next year. But if each individual mine looks at their case study and looks at their supply chain and their location and tries to find their potential clients, their potential buyers or users of their product, then this is going to go a lot faster. So the EU potential adopters of ore sand in the EU, I hope will see this opportunity and start looking from where they are. What is a feasible supply chain for them from the locations where they could get it, which are all in our report and in many other sources as well.
Thanks, Martin. That sounds like a lot of work ahead. Damien, for this project, I mean, you are one of the lead LCA experts out there. And for this project, you also looked into a preliminary LCA for the Valley Sand. You looked into market data. What conclusion can you make on what steps need to be taken on the LCA? And I saw some people already touching base on the ecosystem impacts versus the carbon impacts and what should matter. Mm-hmm.
Okay, thank you, Arno. So yeah, so as Daniel said, I think we have seen in the slide that there seems to be quite an interest in terms of carbon of ore sand compared to river sand or marine sand. But we should not forget that this study was really only a partial one. First, because we did not consider the whole life cycle. We did not consider the use phase and the end of life of the sand containing products, for example, bricks. And according to the characteristics of ore sand compared to the other types of sand, it could be possible that the lifespan would be shorter or longer, as Emil said, or that there is a need for another waste treatment at the end of life due to chemicals or to heavy metals, sorry. So it should be considered to have a complete LCA. The second point is that there is a need for better modeling of the residual tailing of the co-production of iron ore and ore sand, because at the moment, in most of the literature and models, only a very generic way of assessing the impact is applied. So this is not enough because the full potential of reducing tailing could not be assessed. And as a last point, it should be really noted that it's very difficult for the moment. We only showed carbon emissions because it's really difficult to go further than that. Why? Just because when a life cycle practitioner apply the methodologies to compute impact in terms of biodiversity losses or ecosystem damages to ecosystem quality, in fact, these methods do not consider the transformation of the riverbeds or of the seabeds. This means in terms of structure, of flora or fauna. This means that in fact their impact is not evaluated well. So this means there is a need to discuss with the academia to further develop these methods so we can have a real comparison in terms of environmental impacts of the different type of sand. Thank you.
Thanks, Damien. That's very interesting. And I actually heard that several universities are also picking up on this, on evaluating the environmental impact in the marine sphere, in the riverine sphere, on different mining issues. So we follow up on that in the future with you. Daniel, you, I mean, as everyone knows, are one of those world's leading experts on artisanal and small-scale mining. And what are important elements to enable a just transition for artisanal and small-scale miners operating near large production centers of ore sand?
Yeah, thanks for that question, Arnaud. Yeah, I mean, it's very place-based, of course. So as we know, sand provides into local markets. We know that transportation is the main limiting factor for where sand might be sourced for a particular market. So we know that then the challenges, the potential for transitions, the sustainability of sand production is relevant at that very local scale. In the developing world, a large proportion of sand production is by artisanal small-scale miners. We've been working for the last 7 or 8 years with artisanal small-scale sand miners across African, Caribbean, and Pacific states. A lot of those sand miners are mining in circumstances of poverty. A lot of those sand miners are involved in that sector for longer periods of time. It's not a sector that attracts transient workforce in many locations. It's highly diverse though. So each different location is very different from the next. But we do think that there is potential that if you start to add large amounts of ore sand into local markets that have been currently serviced by small and medium-sized enterprises, that there is potential for issues around just transitions. We know that we need to move away from riverine and lake and ocean extraction of sand. So that is a given. But I think that in doing so, we need to work with artisanal small-scale miners on that change and have them part of the discussions, have them part of the decision-making. A few years ago, when I chaired the International Conference on Artisanal Small-Scale Mining in Zambia, we developed the Mosi-oa-Tunya Declaration. And that declaration, because we had a large number of artisanal small-scale miners that participated in that event, really charts a kind of a process by which all transition change that involve artisanal small-scale miners might follow, to have miners involved, to empower them, to have them part of the conversation. Having said all that, there are people that won't want to change from unsustainable practices. So I think that this will be a long-term conversation around solutions, alternatives, and the current production of sand.
Thank you, Daniel. And I think it's a very important conversation to have. So thanks a lot for that. Pascal, over to you. I mean, you are a global reference when it comes to the global sand challenge on sustainable sand management. What makes this solution of ore sand stand out?
Yeah, we have to look at the sand is not many difference from other stories about sustainable development. You cannot catch more fishes than they reproduce themselves. You cannot cut more trees than they grow. And sand was the same, was considered as being infinite. And while it does regenerate itself, it takes a geological time. So basically on a lifetime, any solution has to look at this as a non-renewable resources, because it's just so slow. So we have several solutions that we can use, but to match the volume that we are using, we need to find a solution that has the right potential. And here we have, with the mining operation, those tailings are pretty much the same kind of volumes that we are looking for the sand. So it's got the largest potential. You can also reduce the demand of sand by not wasting it, by having a better recognition for the value of the sand, and just make sure that we are using the amount that is needed and not more. We can recycle concrete to a certain extent. So that's also, especially in close to urban area, that's a very valid resource that we could use. You can recover it from waste, from bottom ash, but it's not the same kind of product. You cannot do all the kind of things that you can do with the normal sand. And so you can change policies, you can get into more technology, you can adapt your lifestyle. There's lots of things you can do, but here we're talking about getting more circularity. It's about making optimizations of the use of the resources. And basically the ore sands got this huge potential in terms of volume, and we saw in terms of proximity, especially in developing countries where we see that mining operations are very close to new developments, where the distance is not playing such a hard role than it may be in Europe or in more developed countries where mining operations are further away from the cities. But in developing countries, we will need a lot of these resources. As I say in my introduction, we'll see population doubling in Africa and still a large increase in Asia. And so ore sand might be a very good solution in many places. Of course, we need to always analyze, making sure that it's the right quality for the purpose, but it has this really large potential in volume, essentially.
Pascal, thank you so much for this. Our time is running up. We have so many questions still to answer. So therefore, I do encourage all the authors to further elaborate on the many questions that have been posted into the chat. And I hand over back to you, Stephanie.
Thank you, Arno. I would like to do a quick check-in with Daniel to see if there's any final words from us, from our team.
Yeah, I guess the last thing I'd say is that this has been such a fun project, and it's been a good collaboration across the partners. It's been great to work with people that are innovating and transforming the mining industry. And the story that Emil shared today is kind of inspiring about how you can be within the circumstances of innovating and change inside a company. Thank you to the huge number of people that attended today. And thank you to everyone that supported the work. There's such huge potential here to do more thinking, to do more analysis. And we just encourage anyone that would like to work with us, both Pascal and my teams are really interested to explore these issues further, to reach out to us and get involved, because it's something that has potential that we'd like to explore, and I think would be great for transitioning the mining industry and the sand extraction industry into more sustainable settings.
Thank you, Daniel. And just as my colleague Josephine has posted the contact of Professor Daniel Franks and also Professor Pascal Patuzzi. So we do encourage any of you who will be interested to contribute to this research, or will be interested in this research, to reach out. And thank you once again, everyone, for joining us. A special thanks to our discussants, and also on behalf of the team, thank you for joining us and taking the time to hear from us and share this journey with us. So thank you, everyone, and wishing everyone a good morning, a good afternoon, or a good evening, wherever you are.